Assalamu alaikum dear students. As you know that we have discussed the three chemical properties of metals, and we are left with the last three chemical properties, that is reaction with hydrogen, reaction with chlorine, and reaction of metal with salt solution. So we will start from the reaction of metals with hydrogen. Before discussing it, I would like to say that as you know that hydrogen is present in the group first of the periodic table in the s block elements or with the alkali metals, but hydrogen is a non-metal. Then why is it placed in the group first? It is because of its electronic configuration. Electronic configuration is the property on the basis of by which elements are classified in the periodic table by Henry Moseley. Hydrogen Hydrogen's electronic configuration matches with the rest of the metals, that is why it is placed in group first. And its properties also match with the group 17 elements, that is halogens, fluorine, chlorine, bromine, iodine, and so on. So its uh, physical and chemical property match with metals as well as non-metals. So it shares both the properties. That means it is electropositive as well as electronegative. When it reacts with electropositive elements, it acts as an electronegative element, and when it reacts with electronegative elements, it acts as an electropositive. But its electropositivity or electronegativity, as per its concerned, it is electropositivity nature is less than that of the rest of the metals. So it is least electropositive than the other metals, and it is also least electronegative than the other halogen atoms. So when hydrogen reacts with metals in these types of reaction, it forms metal hydride. Hydrides are the compounds of hydrogen. When it reacts with metals, it acts as an electronegative element. Because metals are electropositive in nature, in these reactions hydrogen shows the chemical property of group 17 element. And when metals react with hydrogen in these types of reaction, metals lose their electron and hydrogen gains its electron. As you know that the atomic number of hydrogen is 1. It's having only one electron in its k shell or its valence shell, and atomic number of sodium is 11. Its electronic configuration is 2, 8, and 1. So here sodium requires 7 electrons to become stable, but hydrogen requires only 1 electron to become stable. That's why sodium here loses its 1 electron and hydrogen gains electron. So sodium as well as hydrogen both become stable. So this is the reaction. Sodium, when it reacts with hydrogen, it forms sodium hydride, NaH. To balance this reaction, you will write twice. When calcium reacts with hydrogen, it forms calcium hydride. Magnesium reacts with hydrogen, it forms magnesium hydride. So their chemical formula depends on their valency. I will show you how calcium and hydrogen react. Calcium, its atomic number is 20. Its electronic configuration is 2, 8, 8, and 2. And hydrogen, you know, its atomic number is only 1. So why is its chemical formula CaH2? I will show you here. Calcium hydrogen, you have already read it in your 9th class. The valency of calcium is 2, it will lose 2 electrons, and valency of hydrogen is 1, it will lose 1 electron. So you will cross them. Calcium into 1, calcium hydrogen into 2, H2. So chemical formula of calcium hydride is CaH2. So it depends, formula depends on their valency or on their group number. Next is reaction with chlorine. Chlorine is a non-metal and it belongs to group 17. It's an example of halogen element and it is electronegative in nature. When metals react with chlorine or any other halogen atom, they form ionic compounds. And as you know that ionic compounds are the compounds made by the reaction between a cation and an anion. So the compounds of chlorine are called as chlorides or ionic chlorides. When sodium reacts readily, because sodium is highly reactive element, it is highly electropositive element, it reacts readily with chlorine. When sodium reacts with chlorine, sodium loses electron, its valence electron, and chlorine gains the electron, and they form sodium chloride, NaCl. It's an ionic compound. Calcium reacts vigorously, it is less reactive than sodium, it forms calcium chloride. Magnesium reacts with chlorine, it forms magnesium chloride. Aluminium reacts only on heating because aluminium is less reactive than these metals. As I have already discussed it in the last class, that aluminium contains a protective layer, that is aluminum oxide, on its surface, and it will not react with chlorine unless the protective layer gets dissolved. When the layer gets dissolved, aluminum gets exposed. After that it reacts with chlorine and it forms aluminum chloride, or it's also called as aluminum trichloride. Next is reaction of metal with salt solutions. These types of reaction are called as displacement reaction. It is because when metal react with the salt solution of other metal, it displaces. More reactive metal displaces a less reactive metal from its salt solution. Let's take an example. For example, A is a metal, it reacts with a salt solution. BC, it is the salt solution and it must be taken in aqueous form. When they react with each other, A being highly reactive than B, it must be highly reactive than B, then it displaces it, it comes in its place and it leads to the formation of a new salt solution that will be called as AC, and B, that is less reactive, it comes out in the form of solid state. If A is less reactive than B, the reaction will not take place. Its example is zinc plus copper sulfate solution. Zinc, as you know that it is present in solid state, it is present in the form of zinc granules. When it reacts with copper sulfate solution, copper sulfate is blue in color, it is present in crystalline form. At first we have to make an aqueous solution of copper sulfate. After that, put a piece of zinc in the beaker containing copper sulfate solution. There the reaction will take place. Zinc will come in the place of copper because zinc is highly reactive than copper. It will lead to the formation of zinc sulfate solution. It is aqueous and copper will be taken in the form of solid state. And by this reaction, at first the solution is blue in color, after that it becomes colorless. So in these types of reaction, color is changed. Next reaction is iron. It is taken in the form of iron nail plus copper sulfate solution. You have performed this experiment in your laboratory. Aqueous solution and it is blue in color. Iron being highly reactive than copper, it forms iron sulfate solution in the beaker and copper is deposited on the iron nail. The color changes from blue to green. So this is a type of displacement reaction or single displacement reaction. Displacement reaction always takes place between an element and a compound, and element must be highly reactive than the metal that is present in this compound. Next reaction is reaction between zinc plus iron sulfate solution. It is aqueous. And what does this indicate? It indicates that iron is present in solid state, and copper sulfate, it is a salt, but at first you have to convert the salt and it is aqueous solution, and aqueous solution means addition of water molecule. Then in the same way, zinc is present in solid state, iron sulfate is solid, we have to convert it into aqueous solution, and then we have to put a piece of zinc in the beaker containing iron sulfate solution and wait for some time. During that time, zinc will replace iron and form zinc sulfate solution, and iron will be deposited on the piece of zinc. So iron sulfate is green and zinc sulfate becomes colorless. So this is the characteristic that shows that reaction has taken place. So these were the chemical properties of metals. Our next topic will be chemical properties of non-metals.